Alright, 4.1 is over areas of parallelograms, and our essential question is how can you derive a formula for the area of a parallelogram? The first key important term that we're going to talk about is a polygon. And a polygon is a closed figure in a plane that is made up of 3 or more line segments that intersect only at their endpoints. There are a lot of different examples of a polygon. So for instance, a parallelogram could be a polygon, a triangle is a polygon, a trapezoid, because any time that they have at least 3 line segments, so here we have actually 4, and where they intersect, which means this is where they're intersecting, okay, they all have to intersect. So in other words, a polygon, it's a closed figure. It cannot be open. It cannot be like this. This would not be a polygon. So it's got to be a closed figure that's made up of at least 3 or more. That's why the triangle works, as long as it's closed. And then each endpoint would actually intersect eventually. Now that's not what a regular triangle would look like or a parallelogram, but anytime you have a closed figure, it is considered a polygon. To start off our lesson, we're going to talk about the area. And the area of any polygon, remember a polygon is just simply that closed figure, and I say closed, however, my pen's not working the greatest, but they have to be closed. So the area of a polygon, so any of those figures, is the amount of surface it covers. And you can find the area of a parallelogram in much of the same way as you can find the area of a rectangle. And we know that the area of a rectangle equals length times width. So the area of a parallelogram is a little bit different because a parallelogram, and this is actually a parallelogram, because the definition of a parallelogram is just when it has 2 lines that never intersect, so they're parallel on both sides of that figure. So this is what we would look at as a parallelogram, and this is what we'll be focusing on. So kind of those slanted sides. Okay, so first we're going to start off of how do we find the area of the parallelogram. Alright, to kind of sum this up, the area of a parallelogram, let me find my pointer here. So the area of a parallelogram is the product of its base and its height. So in other words, don't forget a couple things here. One thing that's really important to understand is that when we talk about area, it's always a capital A. We don't use a lowercase a because in algebra we use a lowercase a to represent a variable. Well, now we're talking geometry. We always use a capital A, like I show down here, to represent the area. So it's the product, and we know that product is multiplication. So it's the product of its base, and we use a lowercase b and a lowercase h to represent base and height. And the reason we do that is because it is algebra. Now we're saying base times height. So you need to recognize that that is base times height. So looking back up here at my parallelogram that I drew, your height would be determined right here. And it would be represented with a little line like this. And that little line is showing that it's a 90-degree angle. Your height would be right here, so it would be your line up and down. And my base would be this line here, which is represented with our b. Those are the 2 numbers that you would multiply together to find the area of a parallelogram. So I just got done telling you, you're not going to have an uppercase h or an uppercase b because it is actually algebra. There is a number that h represents and that b represents. It could be 2 feet high by 6 feet as our base, and then we would multiply them together to figure out what is our total area, which would be the entire surface of this figure. So this is our first example. It's finding the area of a parallelogram. Get used to spelling parallelograms because you're going to be spelling it a lot. So to start off, if I had a figure that looked like this, and your goal was to find the area of this. So basically what I'm realizing is, okay, my units are in meters, okay? So the base is this line right here, okay? That's 12 meters. My height is this line right here. So that's going to be it's usually a red line or a different colored line when you're looking in the book. But this is my height, and you could always represent and figure out which one is my height because of this little indicator right here. it shows you a little, it's a square. Mine's not perfect in my drawing, but it ends up showing you that that's 90 degrees. That's your height of your parallelogram. This is exactly how I want your homework to look when you set it up. We always do the 3 A's. So we're going to start with A equals, and we write what our formula is. Our first formula for parallelogram is base times height, and you can write it just like that. So you're going to write that as your first step. Then right below it, you're going to put area equals, and this is where you plug in numbers. So now I'm going to plug in those blue numbers. I've got my base, which ends up being 12 meters. So I do 12, and then we're going to multiply it by my height, which is my 14 meters, times 14. I think the book puts it in parentheses. You could do it either way. It wouldn't matter. And then my next A, and it might not be your final A, but in this one it happens to be, because now we can just do 12 times 14. You could do side math if you had to, but 12 times 14 ends up equaling 168. Am I finished? No. Because we're talking about area, we have to put in our meters, and because it's area, it's always squared. So you have to put your little 2 above it. And then this is your final A, so that's the one you would circle. So let me show you another example of what my expectations are. In your homework, in any practice problems you do, this is what I must see. You don't have to redraw your picture if you're working from the book or something, but you do have to have all of this information. Okay, so this one's a little bit different. This one, the picture is drawn a little bit different because it looks like this would be your base here, and this would be your height because it's up and down, and that's how we determine height. However, I told you before, look for your key indicator of the little square, which means it's a 90-degree angle. That is your height. So your height is 4 feet. Your base is 8.5 feet. And you might say, well, would it really make a difference? No, because you're multiplying. However, when we work with different shapes like triangles and that, it does matter what order you put things in depending on that. So you do need to realize that that is your height. So we're going to start off with our first A. We always write the formula. This way I can go back and say, what formula did you use? Oh, you did it incorrectly because you used a different formula. You're going to learn a lot of formulas in this chapter. Your second A is plugging in your numbers. So my base is 8.5 feet. You don't have to put your feet in there. Times my height, which is 4 feet. And then on my final A on this one, because you can do some side math, 8.5 times 4 gives me 34. Remember what your units are. We have feet squared. And this would be your final answer. Here are 3 try-its for you. Remember, you're finding the area. These might be a little bit different looking because of how they're set up. This one should be pretty simple because that's how we just learned it. This one's a little different because your area is on the actual outside instead of having to try and fit in that line right here. They put in the outside for you, so it's really no different. And then this one, be careful because it's kind of on the side. You got to figure out which one's your height and which one's your base. And then make sure you put your 3 A's and solve it, and then I'll give you the answers on the next page and you'll be done. And here's the answers for you. Just be really careful in this, that this is a common mistake I always see with 6th graders is writing the meters in squared. Some kids will just put inches because they're like, oh, I think I worked with inches, and then they call it good. If you put the wrong unit, I do mark you off half point on your test or quiz. So, all right. If you have any questions about these, we'll talk about them in our groups.